All right, I'm first showing all my working answers, and I'm going to kind of zoom in so you can see this a little bit better on certain things there. But we got ratio tests, checking the endpoints, interval convergence on the first part, and then doing some easier derivatives and the A over 1 minus R geometric formula. And then letter D is a pretty easy thing as well. But our leg work here with the endpoints and stuff there is going to be on letter A. Okay, so they give us this guy. And they say use the ratio test, find the interval of convergence. So I need to do the ratio test with this guy right here. So I did the limit as n approaches infinity, and then I just replaced those n's with n plus ones, and I divided it by the original. Remember, when we divided by the original, you multiply it by the reciprocal of that. So do your ratio test, include your absolute value bars, include your limit notation, and remember what makes the ratio test converge is if this answer is less than 1. So you have to set that less than 1. All right, now when you are simplifying this, so this is very typical. So this x minus 4, I rewrote this as x minus 4 to the n times x minus 4 squared. Rewrote this as x minus 4 to the n times x minus 4 to the first. So the x minus 4 to the n's canceled out. And then I had x minus 4 squared over x minus 4 to the first. That's just x minus 4. And then the n plus 1, the n plus 2, those carry down. You can't do anything with those. But with this, you could rewrite that as 3 to the n times 3 to the first. And then that canceled out that 3 to the n. So you just had that 3 on the bottom there. Okay, so practice simplifying that. We've done that a bunch with our ratio test there. Those are fun. I know you don't like checking the endpoints at the end there, but we're going to be okay with that. So you basically get a couple, I think that was like 5 out of the 9 points for letter A. You get a couple points if you're doing your ratio test, if you're doing your limit stuff there, and you're kind of doing that, you get a couple points just for that, and you'll get 3 points if you can get to this point there, finding that interval of convergence, okay? And then they had on the rubric, if you're at least addressing both of the endpoints, trying to check both of the endpoints, to give you another point. So you got 4 out of the 5. And then if you get them correctly and justify that, and getting the brackets in the open part, like converge or diverge for the endpoints, then you'll get 5 out of the 5 right there. But you can get 3 out of the 5 just with this. And if you're trying to do the endpoints, you'll get another point for that there. So we could practice this. We're going to be good at that. And so remember what you do here is you could pull out, I could pull the 3 out as well, but you could pull the X's out in front with the absolute value bars. You can leave the N's up in here, and that 3 could have been out there or left in. It's going to be the same either way. But if that 3 is out there, and then you just got N over N, which is 1, and then if the 3 is in there, then you got the 1/3 right there. And then you can move that 3 over. Now, if they ask for the radius of convergence, that's where I kind of did that. Like that would be your radius of convergence with 3, but interval convergence when you need to keep going further and do your less than sandwich. So you got the absolute value bars to get rid of those, do your less than sandwich, sandwich that in between the -3 and the +3 and add 4 to all 3 parts. And this is your interval convergence, but you have to check the endpoints because when the ratio test is equal to 1, that ratio test is inconclusive. So when you're checking them, you really need to check it. You're going to turn it into a normal converge or diverge like we did earlier in the year. Usually one of these is a little bit tougher. Usually one of these is pretty darn easy. And this stuff that I have in parentheses, you don't need to have. You could kind of do that in your head if you want. You do need converge or diverge and write down the test that you're doing. But if you could kind of do that work in your head, you can just write the test name down with converge or diverge. If you could kind of think about this work in your head, you could just write converge or diverge down with the test name right there. But if you want to write it down, you can write it down there. I just want to make sure we're understanding that stuff clearly. So when I'm checking x equals 1, what I'm doing, I'm plugging it into this guy right here, just in place for the x. So I'm always going back to that original. I'm going to plug in the 1 for the x, and then I'll plug in the 7 for the x. So when I plug in the 1 for the x, 1 minus 4 was a -3 to the n plus 1. And then all this other stuff, I just carried down. And then when I checked the 7, I plugged in the 7 for the x, so 7 minus 4 is 3 to the n plus 1. So that's how I got that. All right, now this is the let's do this. This is the tougher one here. So when I see the negative in there, I'll rewrite that as -1 to the n plus 1 times 3 to the n plus 1. And that means it's going to be an alternating series. And then I'll rewrite that as 3 to the n times 3 to the first because it'll cancel out the 3 to the n's. The 3 is still there, the n plus 1 is still there, but now I have an alternating series. So essentially what I'm doing in my head, the alternating series test, I'm doing this in my head. I'll do the limits and approaches to infinity of that. I know that's zero. And if I replace the n with an n plus one, this thing is smaller than this thing. So those things acting together makes that a convergent alternating series. So they put on the rubric though, you don't need to do all that. If you can do that in your head, you could just write down converge or diverge and kind of write the name of the test that you're doing it on there. So you're justifying what's going on right there. So that means if it converges at one, that means that changes to a bar, which means it's a bracket at x equals one. It converges there. When I plugged in the seven, I didn't have the negative stuff to worry about. I just rewrote that three to the n plus one is three to the n times three. So those canceled out, and I just have this. And sometimes I try to do like the easy n term test or something like that, but that was inconclusive. So what I did a comparison series to like 3 over n. And I had an easy polynomial right there. I knew that this is a divergent P series. If that P is equal to one, that's your divergent harmonic series. And so I did a limit comparison test where I did a limits and approaches to infinity. I did the original divided by the comparison one, which means I multiplied by the reciprocal, and that was just n over n, which is one, which is a finite positive number, which means they both do the same thing. So since that one diverges, I got that this one diverges. So since that diverges at seven, that stays an open interval, and that stays the parentheses right there. So the interval convergence is going to be that guy right there. All right. Now, okay. So letter B, I like letter B. I think you'll like letter B there. It says find the first three non-zero terms in the general term for f prime. So you're just looking at these guys and you're literally just doing your power rule. You multiply by your power, decrease the power by one, take the derivative of each of those. Now, if you multiply by the power, you're taking two, and then that two's on the bottom. So those are just going to cancel out. So when you multiply by the power, the twos cancel, the three's still there, and then you decrease that power by one, it becomes to the first. So same thing here. When you multiply by the power, you're taking three times this, divided by that three on the bottom. So three times that one third. So you're multiplying by that. So when you multiply by that power, those threes cancel out, and then you decrease that power by one, so it becomes a two, and that three squared is just like a constant that's still there. And then when you multiply by the power here, the fours cancel. The three cubed is a constant that carries down, and you're decreasing that power by one. So those are the first three terms. And then the general term is there's two ways that you could do this. If you recognize the pattern, it's just to the first over three to the first. That's to the second over three to the second. That's to the third over three to the third. That's x minus four to the n over n. That's easy. Sometimes it's easy to recognize the pattern. Sometimes it's not. Or you can go to this general term here and you could take the derivative of this. So again, this is just like you have one over n plus one, three to the n. And then you're timesing that by x minus 4 to the n plus 1. So if you're going to take that derivative, this is all a giant number right here. That's a giant number. So when you take the derivative, you're going to multiply by that power. Now, when you multiply n plus 1 times this number, those n plus 1s are going to cancel out. And all you're left with is that 1 over 3 to the n. And then you have your x minus 4. And then when you decrease this power by 1, you're subtracting 1 from that. And so it becomes to the n. And there's your x minus 4 to the n over 3 to the n. I got a little carried away and put the summation thing in there like a being, but no, they just want the general term. So that's just like the general term. You don't need the summation formula up in there. But I typically like those because you kind of see the pattern sometimes, or sometimes you could actually take the derivative of that general term and you got the general term for the derivative. And then that's all they wanted for part B. Part C, they tell us the stuff that we just found is a geometric series. And it says for all x in the interval, show that f prime is equal to this. So remember what the f prime converges to. If it's a geometric series, they want to know what is that sum. So they want you to do the sum of an infinite geometric series right there. And they told you what the answer should be. You're just supposed to actually show it. So if you look at this guy, remember that a is your first term. So here's my derivative. There's my first term. There's my a value. And then each time you're multiplying it by x minus 4 over 3, another x minus 4 over 3. So that's what your r value is as well. So if you use this infinite geometric sum formula, we've seen that before as well. So the a over 1 minus r, there's my a, there's my 1 minus my r. And then all I did here was get rid of the complex fraction like we've been doing all year. So multiply the top and the bottom by 3. So those will cancel out. And then 1 times 3 was a 3. Those cancel. And then make sure you put that in parentheses. And when you distribute the negative, there's your 3 plus 4 to get the 7. And then that's what they asked you to show what it was equal to. So I felt good about that because I've seen that before. Geometric series, show it's equal to something, show it converges to something. That's your A over 1 minus R formula. And so once I did that, I was like, I'm pretty sure I was what I was supposed to do. And then once I got what I was supposed to get, that made me feel good about that. And then part D is actually pretty simple. There's a couple ways that you could justify this. Typically, it's just telling you here, whatever the radius of convergence is for the original function, it's going to be the same radius of convergence for the derivative. And so it just kind of tells us that that's supposed to be like a known thing, that's, but here it says, does the Taylor series for f prime converge at x equals 8? So interval of convergence, that means inside that interval, that's where the thing is converging. The original function converges in that interval. The derivative converges in that interval. And so they said about x equals 8, 8 is outside of that interval. And so they said what would be an acceptable answer if you just put no, because 8 falls outside of that interval of convergence. So there you go. So they said that's all you would need there. No, because 8 falls outside that interval of convergence there. And another way you could prove it to yourself, if you didn't quite like that or you had trouble getting that interval of convergence, here's what you could also do is you could simply take that 8 and plug that in right here. All right, this is the general term. So if I plug in that 8, this is my derivative. They're talking about the derivative. This is the derivative. So if you plug in that 8, I did that down here, you just get 4 to the n over 3 to the n, which is 4/3 to the n. That's an easy geometric series, which is greater than 1. And that's a divergent geometric series right there. So that diverges. So no, it's not going to converge at that x equals 8 right there. So definitely some legwork. We got to practice that right there and study the language and stuff there. But I think we could be really good at a problem like that. So let's keep getting better and better. And let me know if you have any questions. Surround sound speakers. Watch that movie with some surround sound.